I'm also going to hit record too, because we will be recording these sessions for later post on YouTube. So let me just.
I got the recording going.
Oh, you're recording? Okay.
Yeah.
All right. Okay, so let's start with the if-else statements. So like I said earlier, if-else statements are kind of a staple in a lot of programming languages, especially Python. They're used to complete a certain action when a condition is met. So for example, in this tree you see here, the question is it raining outside? If it's true, you should bring an umbrella. If it's false, it is a nice day. So this is like a visual representation of that. And then on the left, you would see that in plain code. So we set raining outside to be equal to true. So in our if statement, it asks if it's raining outside. And since that is true, it would print bring an umbrella. But if that were false, it would say it is a nice day. So Python also includes an elif or an elif statement, which kind of means else if. So it checks only after the if and the other elif conditions aren't met. So for example, in this setting here, it would check. So we set the grade to 88. We would check if it is greater than or equal to 95. Since it's not, we would move on to the next. Greater than or equal to 90, it is not, so we'd move on to the next. Greater than or equal to 80, it is, so we would print a B in this situation, as shown on the diagram on the right as well. So an important part of coding is also checking when things are equal, and also checking and also assigning variables, but there's a difference, although we use a similar symbol for both. So an assignment happens when you set a variable to a value. That would be a single equals. So on the left here, you can see we set x is equal to 3, fruit is equal to banana, and number of equals is equal to 1. So that's important. 1 equals is assignment. That puts a value into a variable. An equality, on the other hand, checks if the left equals the right side. So this is very valuable in our if statements. So on the right side, it shows that if the number of equals equals 2, then you would print equal rights. So the double equals is for checking if the values are the same on the left and the right side. All right, so let's start with a quick question here. What does this following code block print? So I believe this happens as like a poll, and you guys will all get to answer.
Yeah, I launched it.
All right, thank you. All right, so we have 100% answering here, it looks like.
Yeah, is that everything?
Or no, 14 of 20, sorry, my bad.
That probably includes how many mentors do you have? 1, 2, 3, 4, 5.
Okay, yeah.
I think that's
then now we're
everybody
good.
answered. So I'm gonna close the poll.
All right, so I can see that about 27% said less than 20, but then 73% less than 20, and then greater than 0. And so the correct answer would actually be less than 20, greater than 0, and I'll explain why here. So as you run through the code from top to bottom, you'll see that result becomes equal to my num times value, which would be 4 times 5. That's 20. Divide that by 2, 10 plus 4, 14. So 14 is not greater than 25. So it doesn't print that. And then if result is less than 20, so it is less than 20, 14. So that would print less than 20. The trick here, though, is that these aren't elif or elif statements. These are just if statements. So these will run. These will check every single time, no matter if the condition is met. And so it will print greater than 0 as well here, but it won't run this else statement. Even if this so this if evaluates to true, and this else would be attached to the if above it. So the correct answer would be less than 20, greater than 0. I hope that makes sense. And so, yeah, we'll keep it going. So you would earn 10 Ignite points there. So let's start with lists and loops. So let's start with lists. Lists let us keep multiple values in one single variable. So you can create a list of integers in this example. And it's important to understand that lists in Python are indexed and they start with 0. So on the right here too would be indexed at 0, 5, 1, 8, 3. So that's something to keep in mind. You can also change the values of lists. And also a fun fact with lists is you can store multiple different variable types in them with Python. And so here's a little cheat sheet for lists. So you can always get the length of the list by using len and putting in your list variable there. You can also add to a list by appending to the end using the mylist.append. So using the dot operator, which we'll touch on later on in this lecture. So dot append. You can also remove dot remove. It would remove the B from the example list at the top. And then you can also erase everything in the list with dot clear. All right. So loops. Loops are used to repeat code, and they go hand in hand with lists and collections of variables. So the for loop repeats on each list item. So you would type it in as for item in shopping list in this example, whatever your list variable is named, and then it would repeat for every list in there. So it would print eggs, then it would print ham, then cheese, then onions. The while loop is like the for loop, but you have some other condition that you want to be met. And so that's why you would use a while loop. We use a while loop in this course for Pygame to keep our window running when we're running our games, so it doesn't just close out immediately. But in this example, we're using a variable named I to check a condition. And then while that condition is true, it'll run the code in the block here. So while I is less than 5, it'll print I and then add 1 to I. So this will run 5 times and print 0 to 4. And then at the end, it would print done. And then the last one that was ran is put into I. So that would be 5. All right. So another question here. How many times does waiting get printed out in this situation?
I'll keep it open for like 30 more seconds.
Okay, sounds good. All right. So it seems that everybody that answered came to the same conclusion here, that it gets printed out 3 times, and that is correct. And I'll just kind of explain why. So we have a list here of traffic lights. They have strings in them, words, red, red, green, red, green. So for every item in this list as light, we go through that list, we traverse it. So we check each variable and check if it's equal to red and print waiting. Otherwise, we would print go. So this is quite a simple for loop, and it'll basically print out waiting every time you see a red. So all you would really have to do is count how many reds there are in the list. So it would print red first, red second, then it would print go, or print waiting first, waiting second, then it would print go, and then it would print waiting, and then it would print go again. So there you go. That's a couple easy Schulich Ignite points there. So now we'll move on to functions. So functions are kind of a new concept to a lot of people first learning, but I imagine since you guys have already learned a little bit about code or are a little familiar, you might have heard of functions. So programmers like to package blocks of codes into functions so that they can reuse those functions whenever they need to. Using functions makes our code much shorter and we don't need to rewrite code as much. We can just call a function. So this is really nice when we have a lot of repetitive features or functionality that we use in our code. If we find a pattern in our code that we can extract out to a function, we can make our code cleaner and make it easier to reuse and just make it a better program in general. So here's a little bit of the anatomy of a function. So there are only two required parts to a function in Python. So we have the name of the function right here. Oh, what? One sec. The name of the function right on the left there, and then the body. So there's some code that needs to be ran in the function. And then there are optional parts to the function as well. So you can pass in parameters to a function, and then you can do operations on those parameters in the function body. And then you could also return a value. So we'll get into a better concrete example here on the next slide. But this value could be derived, or is usually derived somewhere in the function body, or whatever you need for your function. So as an example, we could create a function that would add two numbers together. So when we think of what it takes to add two numbers together, you think, okay, I need two numbers, right? So that would be two parameters in this case. So two parameters for our function, and we'll call them A and B. If we want to get the value of adding those numbers together, we would have to return something back because sum is defined in this function. If it's not returned, you wouldn't get anything back, or you wouldn't really, depending on what you're writing, it wouldn't do anything to the external function. So it'd be useless. So what we're looking at here is we're taking two parameters, A and B, two numbers, and adding them together into a sum and then returning that sum. So this is like you add numbers all the time. So you could write a function that would do it in one line and other place of your code. So functions are useful only, like you can write as many functions as you want, but you have to actually call them in your program for them to actually do anything. So it's good to think of functions in a way like, or for example, like this. So when you look on the right side there, you have the definition of add is A comma B. So when you somewhere else in your code, you have value is equal to add 3 comma 5. So 3 gets stored into A and 5 gets stored into B. Sum is equal to 3 plus 5. Then we return 8 there. So, and then we can print the value out here as well. So it kind of, instead of, you could also just write your add as one line, but this is just for the example of calling a function. So this calling add value is equal to add parentheses 3 comma 5. That'll call that function for you. All right, let's get on to another quick question here. What is wrong with this segment of code? So we have a function here that's taking in 3 parameters, and it is doing something there. What is it doing? We'll give these a minute probably then, each question.
I'll give it a little more, maybe like 30 more seconds from here.
Okay.
Get a few more answers in. All right, I'm closing the questions. I'll make sure you got an answer in there.
Okay. All right. Okay, so let's go over this line of, or these lines of code here. So at the top, we're defining a function, my function. It takes 3 parameters. And in its code block, we create a value called, or a variable called return value, and assign to it a plus b plus c. So we're adding our parameters. And then we're taking that return value and multiplying it by itself times 2, or assigning it itself times 2. So there, I've noticed that 24% people say times equal is not a valid operator, but in Python it is supported. And then I saw there is something wrong with this function, and the problem is that there is no return value. So we have stated the variable is called return value, but we haven't actually returned anything at all. So, so when we assign value to, or when we call my function and assign value, its return value, it is not being returned anything. So no, there's nothing in value. So this would produce an error. So good job. There's some Schulich Ignite points for you there. All right, let's get into tuples. So tuples are a little bit like lists, where you can use it to store multiple items in a single variable. You can also, like a list, store multiple different types. Like you could store strings or words and numbers, characters, stuff like that. And they're very similar to lists. But after creation, their contents cannot be changed. So while you can access them like an array using these brackets, they are also 0 indexed. If you try to change them, you will be it will result in an error. And tuples are important to learn here in this course as well, because we will be using a lot of them in Pygame. So let's do another exercise. Not a quiz this time, but actually writing some code. So what I want you to do is write code to find and print the smallest x coordinate in a list of coordinates. So an example is shown below. And yeah, let me see what you guys can do here. You'll be put
And
into breakout rooms, right?
yeah, exactly. And I was just, again, if you're with Gurnur, he's not here again, so I've assigned you to different rooms. Your mentors already know that. They'll mark your attendance down for that. And if you think you're in the wrong room, just come back to the main session and we'll put you in the right room. But I think everything should be good. So I'll open the rooms now. All right. I'm gonna join my room too. So if there's anything, just like I'll make you co-host too, just in case. I don't know if
Okay.
you'll need that, but it might help.
All right, sounds good. Do I just hang out in here?
Yeah, you just chilling here.
All right, sounds good.
Hello.
Hi.
Hi. I think
Y-
I was assigned to the wrong breakout room. In my email,
Okay.
my mentor was Jamie, but I was put in Jade's.
In Jade's?
Yeah.
Okay. Let me just double check. I will contact Rohit and I'll see what he can do here.
Thanks.
All right. I sent him a message, but we'll see. Sorry. I'm not sure actually how to assign to breakout rooms.
It's all right. Thank you.
Oh, okay, here we go. You said you're in Jamie's?
Yes.
Okay. Okay, see ya. I think, did you get that?
Yeah. Thank you.
Yeah, no worries.
Hey, just as a quick question about how much time do you think I should give them?
So
Kind of
we're
based.
about halfway done the slides, and
Mhm.
I think a lot of it'll go to Pi game in the end. I'll dive a little bit deeper in depth there. So honestly, you could give them about like 10 more minutes, but like I guess until they're done, basically. Until
Mhm.
because I don't think it should take that long, but
Yeah, and somebody just joined the session too, so I just came back to assign them.
okay. Yeah, any five more minutes maybe?
Okay, that works. But we're with Tony. Okay, I'll put you in Tony's room really quickly. Yeah. Let's name it. Yep, you should be able to join Tony's room now. Okay, I'm gonna go back and check on I'll give them, yeah, about 5 minutes, 37-ish. I'll call them back.
Okay, sounds good. Thanks.
Do you have any idea where the mentees are supposed to submit the exercise answers?
I think they just coded themselves, right? So they're supposed to like actually write the code down.
Yeah, but
There's
like
no sub-
hmm,
I-
like in my breakout room, everyone are done. Like so, like where should they submit that? Like
I'm not entirely sure. It might be a better question for Rahid.
yeah,
Yeah, I'm not too sure. Sorry.
no, no problem.
All right, is that everybody back? No, not yet.
Yeah, everyone should be back.
All right, here, I'll share my screen again. All right, so I hope that everybody had a good time working through this, and I'll just quickly create a new file and show you one of the possible solutions there. All right. So I'm just going to copy this. So what we're looking for is the smallest x value in this list of coordinates here. So we can use for loops to loop through the list here and conditions to check for the x value that is small. So for example, here we would also maybe want to start with a variable that we can define as the minimum. And we could set that to something really big so that when we check against these other numbers, we're not like looking at really small, or when we check against these other really small numbers, we're going to get the smallest guaranteed. So we can loop over the coordinates as such. For the coordinates in the list of coordinates, we can check if the coordinate at its 0th index, which would be the x, is less than the minimum. And then with that, we can assign the minimum to be equal to the coordinate at 0. And then after that, we can print the coordinate. And then this should run, and this should give us the smallest x value in that list. So to run that, we can just do Python 3. Oh, didn't save it. All right. So then just to run that, if coordinate is less than the minimum. One second here. Sorry. For coordinate in coordinates, check if the coordinate is less than the minimum. Maybe this is an issue there. Oh, print. Sorry. There we go. So that would, sorry, I was using a different syntax there for showing the integer there, but that was my bad. I didn't realize that didn't work. And so this would give us the right answer, which would be 18 in this case. And then you could also use the minimum function in Python. So we could just say minimum is equal to min of coordinate at 0 or minimum. And this should also give us the right answer. And it uses a built-in function. So there's already this kind of highlights the usefulness of functions in Python. So minimum finds the minimum value between the two put into this function here. And so that kind of erases some of that code that we needed to write there. So I'm going to start moving on here. But that's the solution to this exercise. All right. So now it's time to talk about the dot operator. So the dot operator is used to call functions for objects. And we have used it before so far. So when I was showing you examples of list manipulation, like appending and removing, the dot operator is what we use to call functions associated with that object. So a list is an object. So we can append milk, add milk to our shopping list. We can remove cheese from our shopping list. So each of these use the dot operator to call a function, and we'll be using the dot operator a lot in Pygame. So it's very important to understand. And essentially also you can chain dot operators. So sometimes objects will have other objects in them, or maybe their methods will return objects that you can chain from as well. So also just to clarify there, I use the word method. So a method is something that is, they're functions that are attached to objects or held by objects. So in this case, the dog has an object that is called its left front paw, and you can call the move method on the object front paw from the dog. Same goes for the right front paw here in this example. So Pygame splits its functions into categories. So all code from Pygame starts with Pygame dot. So for example, when we're initializing our Pygame code, we would start with Pygame dot init, init for initialize. And then if we wanted to use some the image or objects in Pygame to, I don't know, say load an image, we would do Pygame dot image and then use its functions dot load to load, for in this case, a ball JPEG. And we'll see some more examples soon. All right, so Pygame. I assume everybody here has followed the last session, session 0. So they have Pygame installed, but here we'll show you the template that we use for our coding in Schulich Ignite for Pygame. So here, let me just escape here and I'll show you the best way to get this downloaded. So when you click on this link, it'll take you to the Schulich Ignite Flare GitHub repo. GitHub lets you host your code online, which is really helpful, and you can access it using Git, but we won't need to worry about that for this course. So following this README here, you can see that when you're trying to download this file, you click on this here. This will take you to this page. From here, you can save the page as. You would copy and rename this and save it to whatever directory you are. So right now I'm in my Flare directory. I'll just call this, I don't know, main2.py and save it here. And then when I go over to here, you can see the template file is loaded here. So if anybody needs any help with that, just feel free to let us know in the chat, but I'll continue on here. So that template's kind of nice to have for this course because it lets you get up and running without having to write a bunch of initialization code or boilerplate to get started with your Pygame journey. So we can just kind of start with all the fun stuff right away. So yeah, rename it something whatever you want. You could rename it main, you could call it whatever you want, but it's best to call it main just so that when you have help from your mentors, they know exactly what's going on. So we split main.py into 4 sections. So we have a setup section. Here, maybe I'll show you that as I do this. So right here is the setup section. We also have the while true loop, which is what I was talking about earlier. So this loop basically keeps our game running until we decide it needs to quit. So here's this for loop for checking the events and checking if the system needs to quit. There are other events, but we'll get into those later as well. For now, we don't really need to learn that much about them or go into much detail. Right here's the update section. So this is the part where you can manipulate the stuff that you put on the screen. And then down here is the draw section where you can like add colors or draw things onto the screen as well. So this is pre-written for your like convenience. If you find yourself like if you've mucked it up too much and you don't have a lot of like you want to restart, that template will always be online, and that'll be in a format that like your mentors can help understand and help you with the best. It's also a really good setup for that. All right. So let's get a little bit more into depth on these sections here. So the setup section, it prepares everything before the main loop runs. So we initialize our Pygame instance here. And then it's required for all the Pygame modules to work as well. So, and we'll cover what a module is later on in this course. And we also set up the clock to control the frame rate. We also need a screen to draw on. And so we set it up the screen as such with screen width and screen height set to 1800. And you'll notice that these are typed in a unique manner than most of the other variables that we've created in Python. They're in what's called screaming snake case format. So that lets you know as a coder that these values are constant and should not be changed. So once you set your screen size, you should leave it as such for the remainder of the program. So you can create the window here with pygame.display.set mode and give it a screen width and a screen height. Notice how it's in a tuple with the extra brackets in that function. So we're calling this function and giving it this and giving its value to screen, assigning it to screen. So the while true loop, which this is where the magic happens. So when the user inputs something, we handle that in the event section. So mouse movement, key presses, stuff like that. There's also the variable and screen updates like player movement that will be handled in the update section. And then once we've updated our variables, it's time to draw them onto the screen. And that's what we'll do in the draw section. So in the event section, event is something that can happen at any time. That's how most games handle their events, is using like events and event loops. So we'll cover events in a few sessions later. So don't worry about it too much right now. But yeah, that's stuff like clicking the mouse and pressing the keyboard. So in the updates section, that's where we would change the variables and the other logic to run the game. So in this example, the variable X is updated all the time. So every time this loop runs, that value will increase by 3, for example. In the draw section, everything gets displayed. So anything drawn before you fill in the screen will not be shown. So you got to make sure that you have to kind of do it in order, right? So you fill the screen black. If you were painting a picture, then you would draw on top of it with your white paint, whatever color you were looking for. You could put on top, like draw a square or something like that. You wouldn't, if you drew the square first and then filled the screen in black, you wouldn't see anything. And this is a common bug that you'll run into as a beginner. So just try to make sure that you put stuff after you fill the screen in. Pygame.display.flip. This flips the Y and the X axis for it to be easier to manage, like more logically intuitive for programmers. So like I'll explain that in more depth later for sure. And then clock.tick allows you to control the frame rate. So we set the frame rate probably in the setup section. And then now this allows you to slow down to 40 times per second. And then anything after that will be ignored. So keep that in mind. So in our draw section, we can draw images, shapes, and characters. And then also, for example, we can use the function or the method from the screen object .fill to color the screen or the object, or in this case, the screen. So and we use a color tuple. So the values that are put in that tuple are in the format of red, green, blue. And you can go to Google and go to Google's color picker and pick any red, green, and blue value you want from that. And so, yeah, you can use any colors you want. In the previous slides, you would have noticed that there was or in the previous template, there's a black and white already put in for you. So 255, 255, 255 for white, and 000 for black. And those would be in the constants in the screaming snake case. So now it's time to we'll get to setting up our first rectangle here. So we'll use pygame.rect as an object and use that, and that pygame.rect is an object that stores information about where and how big a rectangle is and should be. And please note also that pygame.rect doesn't actually draw a rectangle. It just sets up the information we need to know about it. It is pygame.draw.rect that does the drawing. So keep that in mind when you're for later when we do our exercise. So let's start with setting up a rectangle here. So what we would do is we would create a variable and use the pygame.rect method to create that rectangle. So for example here, we've set the X to be 50, the Y to be 100, the width to be 200, and the height to be 150. So you can see on the right side there what that looks like visually. And then, but this actually right now, this line of code wouldn't have actually drawn that to the screen at this point. And then we're also setting up the red color to be all red, 0 green, 0 blue. So, and then later on in the code, in the template that we've given you, you would find the draw section. And this is where you would use pygame.draw.rect, pass it the screen variable that we would have set up in the setup function, the color, and then the rectangle that we also set up earlier. And then that was what you should see on the right there, a rectangle. So we can also change the position. So you can change the values in the rectangle as you want. And this is how you'll be able to do some cool stuff with your code. Make the rectangle move or something like that, up to you. So we can use the rectangle's X and Y coordinates, width and height, using the dot operator. And they're used just like normal variables. So we can assign to them, we can print them, all that good stuff. So in this example, we're printing the X, we're assigning 300 to the Y, timesing the width by 3, and then assigning it back to the width, adding 40 to the height, then assigning it back to the rectangle height. And then it would change the rectangle as you see above, assuming you've drawn it. All right, so we're going to get into another exercise here. So the goal of this one is to use that template file that we put online to try to make a rectangle move around your screen. And so you guys will be put into breakout rooms for that as well.
Yeah, and I think someone was in the wrong room. If they could just put like a little message in the chat, because I couldn't see exactly who that was. Okay, yeah, perfect. I'll move you then in a second. Oh yeah, well, did you join? If you joined a bit late, I'll just assign you for a room then with Proton. Okay. Okay, you should be able to join now. And wait, what? Wait. I think Rachel is in the right room, no?
Is she? She told me, like, she came out of it and said that she was meant to be in Jamie's, I believe, but I don't
Yeah,
know.
because on my screen she's in Jamie's room.
I think, okay, because I think when she first came out, she said she was in Jade's at the start.
Okay, I mean I didn't move her, but somehow I guess things worked out.
Yeah.
I'm gonna go join my room.
All right, sounds good.
Oh sorry, this is like the last activity, right?
Yes.
So we
So,
can like 20 minutes, I think, 25.
yeah,
So
take
like,
as long as they need. Yeah.
and then yeah, just a 5-minute wrap. Okay, perfect. I'll
Yeah.
reconvene 7:25.
Okay, sounds good. All right, I think everybody's back. All right. I hope everybody had a good time in their breakout rooms and learned some things and got some stuff done there. I just wanted to go over a couple things that I got wrong earlier in the lecture. So, all right. So it was in this instance when I was adding underscores, which you actually can do in Python, and it adds the readability. So when you have a big number, you can separate it. So this should still like print the right answer. I'm not sure what the error was earlier because I closed it before I could undo to see everything that I did. So, but I'll go back in and look at the recording and see what that was. And then also I was talking about pygame.display.flip. And I mentioned something about coordinate systems, but actually what pygame.flip does is it allows you to think of drawing to the screen as like kind of like a little flip pad if you were an animator. So what flip would do is you've drawn everything and then it would update the screen by flipping that paper and putting it on the top. So that's kind of what flip does. So it updates your display screen. So, all right. I wonder, did anybody get the actual rectangle to move? Any of the mentors want to chime in? Okay, interesting. So I'll go through the exercise that I have here. So basically, I'll show you what I have here. All right, so here's an example of a rectangle moving around the screen and bouncing off the sides. So what we did here is in our setup, which is where you set up your initial values and stuff. We created a rect at 0, 0. That was 500 or 50 width and 100 height. We set the speed to 7 and the speed in the X direction to 7 and the speed in the Y to be 5. And so in our update section, this is where we're gonna this is where we would have manipulated our X and Y values so that we could update it on the screen. So we set the rectangle's X to be equal to the X of the rectangle plus the speed value. So this would be, when it was in the top, it'd be 0 plus 5. So it'd be 5, then it'd be 10, so on and so forth. No, that was 7. Yeah, it was 7. So 7, then 14. And then for rect speed Y, we do the same. So we change the X and Y coordinates as the program loops over itself. So there's that. Then we check in this if statement if the rectangle has gone out of bounds horizontally. So we check if the X value is less than or equal to 0, or if the X is plus the width is greater than or equal to the screen width, which we've set up here to be 1,000. So that makes it bounce off the actual bounds of the screen. If we didn't include the width there, it would be cut off a little bit. And then when that happens, we change the X speed to be -1. And then the same goes for checking for the horizontal boundaries. We check if the Y value of this rectangle is less than or equal to 0. And then, or if the rectangle plus or the Y plus the height is greater than the screen height. And then we would flip that again. And then finally in the draw section, we've done all this updating. We actually have to put it on the screen now. So after the screen fill, we put in the pygame.draw.rect. We feed it the screen, the color of the rectangle, and then the rectangle itself. And then we use the pygame.display.flip to do that. And then we set it to the proper frame rate. So we're limiting it to, I believe it was 60 frames here. So if you guys did something like that, or if you just moved it around the screen, that's a big step. For the next session, I believe we'll go into more depth into Pygame, as well as we'll look at objects and classes and stuff like that, and more object-oriented programming design, which is something we'll learn more about in the next session as well. Yeah, did anybody have any questions or anything like that?
Is there
You
any
don't underst-
places where I can access like notes and stuff since I wasn't here for session 0, just to make sure I can like catch up on things and just reread things in my spare time?
I can send you the session 0 link if you want, just before you go.
Thank you. Yes, please.
Also, if
I'll
you
put
go
it
to
in the
sh-
chat.
if you go to
Thank
the Schulich Ignite website too, you can find the slides under the Flare section as well. They'll be
Okay, thank you.
posted the day of. Yeah, no worries. What screen.set alpha does. Okay, so that is more of an in-depth thing that we'll cover later on. But for example, if you had like a PNG, you would know that the alpha bits, or like the alpha is the transparency. So this is setting those bits to be considered transparent and not a different color, like, or rendered in like black or something. It would actually make them transparent so you can see through them. Are there any other questions?
Oh, and just before you guys go, I'm sorry, I forgot, like, there's an end of session quick question that I have to put up.
Yeah.
So just give your quick feedback on the session about the pacing. Okay, I think that's most people answered, so I'll just close this one. So that's a lot of you, some of you found it just right, and a few people did say it was a bit difficult. So yeah, I know it's a little bit of a learning curve, but we'll be here to help you on the way. So we'll try our hardest and all to assist you with any problems that you have. So rest assured you're in good hands. And one more quick question is this. Just give a little insight on how the pacing was.
Okay.
Okay. So yeah, some of you said it was a little bit, most of you said it was good, which is nice. And in terms of the pacing being quick, we'll try and work on it a little bit. It's sometimes a bit difficult because we do have a lot of content to cover, but again, I think you guys, after a little bit more practice and all, will start to feel as if it's a bit more appropriate. But yeah, that's all from my side. So yeah.
Yeah. Okay. Yeah. Thanks for the feedback, everybody. I really appreciate. I'll take that into consideration. I'll try to make it maybe not quite as fast. I'll try to tone it down a little bit on the speed there. A lot of the session today too was I was under the assumption that a lot of this was kind of already kind of known. But if you guys have any questions, I'll be on the Discord as well. My username is LL-John, so I'm the lecture lead. You can DM me anything you want on there, like any questions or any comments. You can join the Discord also through Schulich Ignite, like the schulichignite.com. But yeah, if there's no more questions, thanks for everything today. Thanks for coming and joining and working on the exercise with the team. Yeah, have a good night.
Thank you.
Yeah, no worries.
Okay, yeah, I think let's pause the recording.